Hello. Today my team members and I would like to present what we've been working on over the last 8 months. First, I'd like to introduce everyone. We have Richard Yang, an animation major in CGT and our VR expert for this project. He was responsible for researching and piloting the virtual reality experience. Next is Milan Patterson, a building information modeling major and a communications liaison for this project. She was responsible for most of our email correspondences, reaching out to industry leaders, and scheduling meetings with our sponsor, as well as keeping our project documents in order. Next, we have Avery Thompson, also a BIM major, and our assistant project lead. He has been responsible for researching the process in depth in order to complete the project model in Revit. Next is Kushal Sabir, another BIM major and modeler. Kushal has been responsible for modeling and research and completing the initial model of the project in SketchUp. Last is myself, Dallas Brown, majoring in BIM. I was the project lead responsible for maintaining the collaborative processes in the team. And we are Smart Tech Design Technology.
In the early stages of our project, we decided that our problem statement would be, at the early design stages of construction, it is difficult to conceptualize the components that make up a structure or building with entry-level knowledge, causing there to be a steep learning curve in construction. Our experience from CGT's 262 was trying to identify everything in the wall section, which the picture on the slide shows. It is difficult for many students to conceptualize how everything goes together. And a major limitation of learning through wall sections is that we don't have a 3D aspect. So this can lead to issues, especially when there are special cases like corners for walls and other components. Moving forward through the BIM program, students need to be able to conceptually understand plumbing, HVAC, and other systems where things such as section views and overhead views are not as easy to understand. Another study written by Beverly Bartmans and Cheryl Sorby, Development of 3D Spatial Visualization Skills, noted that 85% of people learn by sight and that visualization skills are needed to enhance this method of learning in physical sciences like engineering. This study also observed that academic requirements for graphics understanding have continued to decrease, while changes in technology have since increased the demand for improved spatial cognition. The authors, Sorby and Bartmans, concluded that one's personal background and life experiences were highly correlated with the student's spatial abilities. The decline in experiential education opportunities in the education process necessitates the need to replace these experiences with a suitable tool to help in the development of spatial and visualization skills. So we decided to decrease the learning curve that our project would be to create a virtual reality model of a small home that can be easily manipulated through a headset or the computer with label components so that the students can better visualize the construction of a small home and all of the components that make up a small home. Our stakeholders throughout our project were our sponsor and mentor, Clark Corey, an associate professor for the Computer Graphics Technology Department and the head of the BIM department. Our professors, Carlos Morales and Travis First, both associate professors of the Computer Graphics Technology Department, and our teaching assistant for the Computer Graphics Technology Department, Cassidy. We also worked with industry professionals from Holder Construction Company, Messer Construction Company, Satterfield and Ponticus, and the Envision Center, as well as higher level construction education, including college and trade school students and professors. We would like to especially thank our sponsor and mentor, Clark Corey, for all of the hard work that he's done to help us throughout the semester, as well as the professors and the teaching assistant. We would also like to thank everyone for joining the presentation today. As discussed with our mentor and sponsor, our job working on this project was to create a 3D model of a small home that can be easily viewed and manipulated through a virtual reality headset. Our model will include foundations, floor joists, siding, wall panels, wall studs, rafters, and roof sheathing. And each of the components will be individually labeled. While working on this project, we will not be creating a site plan or a landscape plan for the 3D model. We will also not be creating complete construction documents or creating high-definition rendering packages for the Revit or SketchUp model. Our VR demo will stand as our high-definition render.
This is our project Gantt chart covering everything we did for the entirety of the project. For the project schedule, we broke everything down into 5 stages or milestones. For the first milestone, it consisted of creating the initial Revit model of the building for VR use, complete with the structural and architectural components as well as material finishes. The second milestone of our project involved a bulk of R&D, essentially finding a majority of the information we need to implement the initial model into the VR space. For this, we conferred with professors, construction industry leaders, and experts in VR. The third stage of the project was the meat of the work and included modeling the final building for VR use and choosing the best suited software. After more feedback from our sponsor, we tailored the model to be loaded into the VR space with all necessary detailing. The fourth and fifth stages of the project needed adjustment due to the coronavirus and social distancing. The fourth stage of the project still included completing suggested revisions and finalizing our model, but expectations were moderated as far as the degree of interactivity inside the model. During the fifth stage, we could not collect data to determine the success or failure of our final product since we are unable to perform testing with students. We will deliver the project to Clark Corey and complete the final presentation as this video. The major milestone for this stage is delivering the project as it signifies the completion of the project. Our objectives were Clark's initial expectations based on our capabilities and are as follows. Option 1. Provide a 3D model, whether it is in Revit or SketchUp, as long as students could view the components via the labs in Noi. Option 2. Import the model into the VR interface, but can only edit it on the computer and reload it into VR. Option 3. Import the model into VR workflow and move materials, explode the model, and fully interact within the VR space while using the controllers. The solution we accomplished was a combination of options 2 and 3. The model can be changed outside of the VR realm, but while inside the VR model, you can hide and unhide components to reveal ones beneath the surface using the controllers. The system is meant to be a practical learning tool for students in the future and intuitive enough so that users with very little experience could understand how to effectively operate with little instruction. The most important outcome is for students to use the system as a clear learning tool, while conserving the usability aspect since our end users have less experience using VR. Originally, we had planned to test the learning system on the CGT students who we surveyed last semester and are now taking 360 this semester and compare it with the feedback from a new group of students who are currently taking 262 this semester. We plan to ask about the overall usability and whether or not it would be an effective learning tool for them or other students in a similar position. Due to the nature of the test and COVID-19 preventing personal interaction, we must rely on Clark Corey for feedback. We worked with him all semester making sure there weren't any missing features or anything that could be adjusted to improve the product, and specifically if he would implement this into his curriculum. Our measurable project objectives are based on SMART goals. The acronym stands for specific, measurable, attainable, realistic, and time. S standing for specific goals are to create a VR model of a small home where every individual component can be manipulated to help students visualize the makeup of a building. M for measurable goals are positive, unbiased feedback from the project sponsor and mentor, Corey. This is attainable because our group has the skills, technology, and resources available through Purdue Polytechnic to execute this project. This is realistic because the educational materials and VR technology needed are currently used in industry. We just need to combine them in a logical, easy-to-use medium. The time frame for this project is 1 semester.
As previously mentioned, it is difficult for students in the BIM course CGT 262 to identify everything within a wall section, and it is also difficult for students to conceptualize how everything fits together. So, for our initial research, we conducted interviews with the students in the intro-level BIM course CGT 262. The question on the screen shows, if they would be comfortable taking a quiz over the wall section provided. As you can see from the results, almost half of the students would not be comfortable taking this quiz. We also asked questions such as if they've ever used any VR or AR products before. If they have, how much exposure have they been involved with? What specific VR and AR products have they experienced? If they agree or disagree that current BIM technology should support a more immersive VR experience. And finally, we asked if they believe they would benefit from a virtual construction lab that utilizes virtual reality to see and manipulate all components of a building from framing to exterior work. And as you can see on the next slide, we dug deeper into our research by talking with industry professionals and how they benefit from using virtual reality on their job sites.
Maria Hornsby is an augmented and virtual reality expert at Messer Construction, so I reached out to her to ask for some advice on what platforms to use and how to get the momentum going for our project. She mentioned Insight VR and Iris VR, which have great viewing coordination capabilities in the VR realm, but didn't have the level of interactivity that we were looking for. She then told me about Unreal Engine and Unity, and the main differences between them, that being Unity is more user-friendly for beginners, but Unreal Engine has more plugins between other programs and the graphics are more realistic. We also reached out to Nick Alfonso and Andrew Simner from the Purdue Envision Center in the basement of Stewart, and they were able to give us insight on a great workflow. The proposed workflow was to start modeling in Revit, then export the model as an FBX or OBJ, and edit it in either 3ds Max or Maya. Another option was to start from scratch in Maya or 3ds to avoid too many problems that sometimes occur when converting from Revit files to FBX. Within either 3ds or Maya, go through and check the model, remodel any objects that need it, and after the objects are perfect and the UVs are good enough to add textures, then the model can be imported into Unreal or Unity.
During the development stages of our project, we talked with Holder Construction Company to learn more about common virtual reality and augmented reality tools used in the construction industry. We spoke with Alice Cole, Ryan Cutler, Alex Edgar, Ian Trunk, and Joey Rodriguez, all currently serving as VDC engineers or alongside them. From them, we gathered that using tools such as AR glasses, OpenSpace, BIM 360 Glue, Fuser, and Google Cardboard assist in the everyday logistics of the construction world. It is very helpful when working on clash detection and coordination throughout the project. One of the major things we took from the conversation was Fuser, a software that offers an integrated design environment for architecture, engineering, and construction professionals. In Fuser, you are able to combine Revit, SketchUp, FBX, and other file types to experience your full model in 2D, 3D, VR, and AR. As previously mentioned, Fuser is a software that offers an integrated design environment for architecture, engineering, and construction professionals, brought to our attention through our interview with Holder Construction. In Fuser, you are able to combine Revit, SketchUp, FBX, and other file types to experience your full model in 2D, 3D, VR, and AR. Over the course of several weeks, our mentor and sponsor, Clark Corey, spent many hours working to get us access to the educational version. We also spent many hours learning some of the interface and software capabilities through the educational viewer limited version provided to us by Erica Jamison, working with Calyx Studios Incorporation. Though the BIM department agreed that using Fuser will be beneficial to the students and professors working in the BIM department, it was ultimately decided that using Fuser would not be plausible due to the time it would take to get its funding approved, and it would not allow enough time for us to learn and execute our purpose for using it.
I model similar house we model in the Revit file with details. Also, I sketch it in the SketchUp with the same dimension I have in the Revit file. And this in the SketchUp is they have a lot of issue. They have the first issues is like it's really hard to rotate it and see what it clear. Also they have it's already hard to find exactly material with the I have used in the Revit file. You can find it in the SketchUp. That's the other issue. Also, they have a lot of time and consuming compared to the Revit file, and also they have when I change the the SketchUp to the IGS file, and when you to create it for VR. And this file is just too big and too many faces. Is when you open it, it takes too much time to open it, and it's loading, and also when they crash the computer, the file is just too big. It's not compared to the Revit. This is easiest way to load it in the VR.
After the first presentation, it was our intention to use 3ds Max for all of the modeling of our project. Throughout our research, we found that while this was an option, this was not the only option when it came to modeling for our purposes. Through the Purdue Envision Center, we found we could use Revit for the modeling and then move it via a .fbx file to 3ds Max to finish up any final features, namely anything that is curved. From there, the model could be imported into Unreal Engine to add VR functionality, textures, etc. So, a mile-high overview of our process was to do all of the rectangular modeling in Revit, which comprised 99% of the modeling. However, the last little bit had to be done in 3ds Max due to the triangulation of everything modeled in Revit. Essentially, anything that is curved was modeled in 3ds Max to improve the performance of the project when viewed in virtual reality. The model was then exported from 3ds Max to Unreal Engine to add textures, and also the virtual reality aspect. We chose to use Revit for the majority of the modeling as opposed to 3ds Max, partially because of our much more extensive experience and knowledge of the software, but also because of how it applies to what Professor Corey teaches in class. In the BIM program at Purdue, Revit is the main software that is taught. While 3ds Max is used for certain parts of construction, such as rendering, Revit is a much more industry standard software. The process that we use to create the model could be recreated by students in Professor Corey's courses, only having to learn how to use Unreal or Unity engines instead of an entire modeling software as well. We then chose to use 3ds Max over a program such as Maya for the remaining modeling because it is used in construction, whereas Maya is not very common for that industry. When it came to software that could be used for the VR aspect, we had three main choices: Fuser, which was talked about previously, and then Unity and Unreal engines. Fuser is not an option for us, and when it came to Unity or Unreal, it was a real toss-up. Ultimately, the choice came down to Richard's past experience with Unreal, and the time commitment that it would have taken for him to learn and test Unity for the purposes of this project. While Unreal is agreed upon by most to be harder to use, Richard's experience put it a leg up on Unity for what our project is trying to achieve. To speak specifically about the process of what was done in Revit, the first step was to come up with a basic model. To do this, I used the base tools that Revit offers and modeled in things such as walls, floors, footers, roof, stairs, windows, and doors. The intent of all this was to create a floor plan and a template that the rest of the model would be based on for the entirety of the project. From there, it was time to start increasing the level of detail of the model. So I then modeled in as much as possible with the built-in Revit tools. To give an example, the floor joists and roof rafters can be modeled using the tools in the software. To continue adding more detail, the family modeler in Revit had to be used. Families in Revit are objects that are grouped together as one model. This is where things such as the wall framing, corner boards, and more or less everything that needed to be explodable was modeled, with the exception of the curved parts as I previously covered. At this point, how the models are created comes into play. In Revit, anything that is in a family will import as one object in other softwares down the line. So in order to work with this, for the fully explodable wall located on the right side, all of the individual pieces, such as wall studs, sheets of plywood for sheathing, single pieces of siding, etc., are individual families. Whereas elsewhere, for example, the wall framing is one family and therefore one object in 3ds Max and Unreal Engine. After modeling the families, they were all painstakingly added to the template model in Revit and placed in the correct location. At this point in the process, the single explodable wall is fully modeled, and what is left to be done is the wall and floor coverings for the rest of the house. To do this, thin individual walls and floors were added from the built-in Revit tools. Special care was taken to make sure that the materials were set correctly and that clear naming conventions were used throughout for clarity. Once this was finished, the model was viewed in a companion rendering software called Lumion so that any errors could be more easily visualized and corrected. This software was particularly helpful in proofing the model due to a live sync feature and the first-person nature of the software. From here, a few small details were corrected and or added in 3ds Max before the .fbx file was sent to Richard, who will now talk to you about his work on the project.
So these are the steps and process I did in Maya and Unreal. Since I have more experience in Maya than Revit and 3ds Max, and due to the complexity of the original model that was exported from the software, I decided to remodel the doors and windows for better texture mapping and light baking in Unreal Engine. So I just getting rid of the unnecessary parts and faces of the model to create new UVs. Then I basically just transport all the files into Unreal, then finish up the rendering. And this is my workflow for Maya and Unreal. I used the blueprint system, which was built in the Unreal Engine to create certain functions for VR interaction. And since Unreal's blueprint has a significant advantage for visual scripting, I use this node-based blueprint for my VR development. And the picture on the left basically shows how I did the pointers for the controllers and how I used them to execute the animation, which for opening the doors in the building. And these details will be later explained in the demo video as well. So these are the stuff I did in Unreal, which was for the certain VR function as well. And some of them came along with the Unreal Engine blueprint system. And for the first one, the nodes which is used for hiding layers, these are the ones I created for hiding the layers the pointer's pointing at. And the second picture shows basically how I imported the mesh of the Oculus controller, since we are using the Oculus headset instead of the built-in hand mesh in the Unreal Engine, and what that looks like for the teleport icon. And the third one basically came along with the blueprint system itself. It's for the teleporting using VR handles. And the last picture is the controller layout I created for especially for the Oculus and for this demo reel. So this is part of the nodes I created for the refreshing function. For example, the layers on the left are the ones I referenced out from the original object, are the layers of the walls. Then I connect them to the target to execute the function of refreshing everything to set them to make them reappear in the scene. And since there are so many layers, I just have to connect every single one of them, because node system is basically like coding. There's just no like shortcut to do it. And this is the final look of the blueprint after I am done with everything. And this makes it really easy for people to use the controller to manipulate the layers in the scene. Hello everyone, we're Smart Tech Construction Design, and this is our VR demo. First of all, we're gonna need to set up our VR devices. Make sure your headset and controllers are connected and ready to go. Now, open the project folder, click on the Unreal project, and wait till the Unreal Engine show up. After we go into the interface, at the bottom left corner, click on Content. This will bring up all the folders that we have in this game. Click on Maps folder. This includes the map level we're gonna need for the VR experience. After opening the level, we're gonna go to the top and click on Play, then choose VR Preview. This will bring us to the VR viewport. This is our controller mapping. We're using the two front buttons for hiding layers, and for the left controller, if you squeeze the button on the side, that will refresh all the layers that's been hidden. If you do the same to the right controller, that can help you open the door you're pointing at. To teleport, just simply press the joystick and pick the location and release the joystick to teleport. Now we're entering the VR experience. We're using the pointers on the controller to choose the layer that we want to hide. Simply point at the layer, then click the front button. The layer will disappear. If you want to refresh all the layers that's been hidden, squeeze the side button on the left controller. By squeezing the side button on the right controller, you can open the doors you're pointing at. After getting familiar with auto controlling, you can now enjoy our VR experience. All of our 3D assets were created in Revit, 3ds Max, and Maya. The textures are from Quixel Megascan, and some of the foliage files are from the Unreal library. I hope you enjoy our VR experience. Thank you for watching.
So throughout this project, we've talked to industry leaders, experts in VR, figured out what softwares are available for VR in construction, discovered a great workflow from Revit into Unreal Engine, figured out what worked, and did not get discouraged when things didn't go our way. This year, we've learned how to work with each other's strengths and weaknesses to create a product that benefits our majors. We learned to be open-minded because there's more than one way of achieving one's goal, and that technology is ever-changing. We were fortunate enough that Richard had the VR equipment and software at home to be able to complete the VR portion of this project. This project has opened a new door for students to learn BIM in an interactive way and see their buildings in real time. We think that over time, implementing this tool will be an interesting and modern twist on traditional learning tools. With more utilization of technology and resources Purdue has to offer, this system can be perfected, adjusted, and reimagined for Clark's BIM courses. It has been a real pleasure working on this project with Clark Corey and assisting him in helping educate future BIM managers. We encourage you to comment any questions you may have. Thank you.